Today we will start our new chapter, that is alternating current. So in the last class already we discussed what is meant by AC, whose polarity is continuously changing at each and every instant of time, value also changing. Such type of voltage is known as AC voltage, or current is known as AC. Okay. So if we are plotting, we can see that this will be like this. So if we are writing E is equal to E0 sin omega t, here omega t is plotted. So we can say that it will be a sine or cosine curve. So here we can say that it is a sine curve. Okay. Clear? So at each and every instant you can see that value of EMF is changing. At this point the EMF is this value. When it reaches here, EMF is this value. At omega t is equal to pi by pi. EMF value is 0 and so on. Okay. Is it clear? And in this chapter we are going to discuss about some terms that is needed to use when we are using AC voltage or AC current, and if we are applying AC voltage to a capacitor, resistor or inductor, what happens to the current, all those things, and what is the expression for the power and all those things that we will discuss. Okay. So already you know that here omega, what is omega? Omega is angular velocity. No. Omega is the angular velocity, and it is related with the time period as omega is equal to 2 pi by t, or we can write it as 2 pi f. 2 pi by t or 2 pi f. That is the relation between omega and t is the time period, f is the frequency, and omega is the angular velocity. E is the instantaneous value of the AC voltage. E0 is the value, peak value. Okay, is it clear? And now here we are going to discuss about mean value of AC for one second. Mean value of AC for one time period. Mean value of AC for one time period. Okay. So what was mean value of AC for one complete cycle? So if your one time period means, if you are considering full time period, what is the mean value of AC voltage in the AC? Okay. So we know that the instantaneous value of EMF, if it is given as E0 sin omega t, same here we can write instantaneous value of current can be written as I0 sin omega. Instantaneous value of current can be written as I0 sin omega. And I can be written as dq by dt. So we can write dq by dt is equal to I0 sin omega. And dq can be written as, because at each and every instant the charge flowing or current flowing through the circuit is changing because it varies sinusoidally. So dq can be written as I0 sin omega t. So here which is the variable? T is the variable. So we can find the total charge. Q can be written as integral 0 to t by, because t is the variable, I0 sin omega t. I0 can be taken outside the integral. So I0, if you integrate sin omega t, what you will get? Minus cos omega. minus cos omega t divided by omega between the limits 0 to 8. Okay. Omega can be taken outside because omega is 2 pi by t, does not vary with t. So we can take plus is equal to I0 by omega, or minus sign also if you want you can take minus I0 by omega. Now what we have to do, we have to apply upper limit and lower limit. No, so upper limit minus lower limit. So this can be plus, instead of omega we can write it as 2 pi by t, 2 pi by t into t. Here instead of omega we have written, instead of omega we are writing 2 pi by t into t minus lower limit is 0. Cos 2 pi is 1, cos 0 is 1. So total charge is 0. Why it is 0? Here 1 minus 1. So total charge can be 0. So total charge is 0 means current. Mean value. Mean value for one cycle can be written as total charge divided by total time taken. Total charge is 0, total time taken is 0. So mean value of AC for one time period is 0. Okay. Mean value of AC for one time period is 0. Is it clear? So here whenever we are measuring that DC current, already you know that we are measuring with the help of we can measure the we can detect the presence of current by using galvanometer, or we are using ammeter. That ammeter itself it is converted galvanometer only, no? And that depends on the magnetic effect of current, which depends on the direction of the current. But here in the case of AC, what happens at each and every instant of time, after every half cycle of rotation, the direction is getting reversed. No? So when we are using normal ammeters or galvanometers or normal ammeters to measure the current, what happens is that this pointer, even though it will move, because of persistence of vision, it appears to be stationary for us when we are measuring. That's why normal ammeters cannot be used to measure AC current, and there we are using hot wire ammeters. Okay. We are using hot wire ammeters. So from the word itself it is clear that hot means we are using the heating effect of current, and this heating effect of current does not depend on the polarity or direction of current. Whichever whether it is moving from whichever direction in a resistor, for example, if it is moving from A to B or B to A, immediate heat energy will be dissipated. So here to measure AC voltage or AC current, we are using hot wire ammeters and voltmeters, which depends only on the heating effect of current and not on the magnetic effect of current. Okay, is it clear? And now we will discuss the mean value of AC for T by 2 period. Mean value of AC for a time period of T by 2. So already we have seen that average value of AC is 0. While for one time period corresponding to each positive value there will be a negative value which will be added up to 0. Okay, that mathematically we can show also. So here we are finding mean value of AC for T by 2 period, and that we used to represent it as I mean. Okay, how to find I mean? You can find total charge divided by total time. And here time period is T by 2, not T, it is T by 2. So same expression we can write I is equal I0 sin omega t, dq by dt is equal to I0 sin omega t, or dq is equal to I0 sin omega t dt. No, all those steps same only. So we can write q is equal to integral 0 here. Sorry, here it is not t, it is time period, no, t. One time period, full time period. So here instead of that we have to write it as 0 to t by 2 I0 sin omega t dt. Or we can write it as I0 can be taken outside, sin omega t if you integrate minus cos omega t by omega between the limits 0 to t by 2. Minus I0 by omega can be taken. Cos omega, you can apply the limits. So cos omega is 2 pi by t into t by 2 minus cos 0. That's only the difference. There it is t for one time period and here it is for t by 2 period. Okay. But you will get cos pi minus cos 0. Cos pi is minus 1, cos 0 is 1. So you can write it as minus I0 by omega into cos pi is minus 1, cos 0 is 1. So you will get it as 2 I0 by omega. And omega can be written as 2 pi by t. So 2 I0 divided by 2 pi by t. And this is the total charge. If you want to find the current, you can write it as mean value of AC is equal to total charge by time. Total charge is I0 t by pi divided by t by 2. So that can be written as 2 I0 by. Okay. This is the mean value of AC current 2 I0 by pi. Same way we can say that mean value of AC voltage can be written as 2 V0 by. Is it clear? So when it is asked to find the mean value of AC, don't find for one time period. One time period if you find, you will get it as 0. So here we are finding only for half time period. That is, that expression is given by 2 I0 by. Okay. So mean value for half time period is given by. It is already understood that if it is not mentioned, it is understood that for half time period, and that is given by 2 I0 divided by. So this expression is very important. Okay, is it clear? Now we will discuss about RMS value. RMS value of. So RMS stands for root mean square. Last year we studied velocity. No, root mean square velocity in kinetic theory already you have studied. So here we are discussing about the RMS value of AC voltage or AC current. Okay. So what is meant by RMS value of AC current or AC voltage? So it is that DC current which pass through any resistor or material which produces the same heating effect as that of AC voltage which passes through for the same interval of time. Okay. So if a particular AC voltage is passing through a resistor for a particular time duration and it produces some heat energy, and to produce the same heat energy, whatever DC current to be flowed, that we can say it as RMS value or effective value of AC. Okay, is it clear? Understood? And this RMS value of current, it is represented as IRMS. So we are considering a resistor. Resistance is R. that resistor, heat energy is current is flowing for a time interval of t. T is the time period. So the expression for heat energy can be written as heat energy dissipated can be written as I RMS square R. Okay, heat energy dissipated. Now we can find heat energy by using that AC value also. No? AC voltage current is given. I is equal to I0 sin omega. So we are considering a small interval of time dt. So for small duration of dt, we consider current remains same. Current remains same for a small duration of dt. And what is the expression for the heat energy produced that for small duration of dt? That we can write dH is equal to I square R into dt, and I square can be written as I0 square sin square omega t R. This small amount of heat energy. And how to find the total heat energy? Total heat energy can be found out by integrating. Now here which is the variable? T is the variable. So 0 to t I0 square sin square omega t R. So this is our expression 1, so equation 2. So we can say that according to the definition, this heat energy should be equal to this. So we can equate both sides. What we will get? I RMS square R T is equal to I0 square R can be taken outside. Integral 0 to t sin square omega t dt. R can be cancelled. Now we have to integrate this part. To integral sin square omega t dt. So that we can do integration here. So we are finding integral sin square omega t dt between the limits 0 to and we have to integrate. And what is sin square theta? Sin square theta can be written as 1 minus cos 2 theta by 2. So here this can be written as integral 0 to t 1 minus cos 2 omega t divided by 2 1 by 2 can be taken. Integral 0 to t dt minus cos 2 omega t. If you integrate dt, you will get it as t. And if you integrate cos 2 omega t dt, what you will get? Each if you want, you can separate also. If you integrate cos 2 omega t, you will get it as sin 2 omega t divided by 2 omega between the limits 0 to t. Okay, now 1 by 2 into, you can apply limits. So upper limit is t, lower limit is 0. So for this t minus 0. And for this 1 by 2 omega can be taken common. Now we can write it as sin 2 into 2 pi by t into t. Sin 2 omega is 2 pi by t into t minus sin 0. Okay. Or we can write it as 1 by 2 into t. And here sin 4 pi, what you will get? Minus 1 by 2 omega into sin 4 pi minus sin 0. Sin 4 pi minus sin 0. Sin 4 pi is 0, sin 0 is 0. So this term will vanish, and what you will get? You will get it as no. You will get only t1. Okay. So that you can substitute here. So what you will get? I RMS square t is equal to I0 square into t divided. So if you integrate this part, you will get only t1. So we can write IRMS is equal to I0 by IRMS is equal to I0 by, same way we can find VRMS also, same way we can find, so that we are not discussing here, so that we can write it as V0 by, so IRMS is I0 by root 2 and VRMS is V0 by. So whenever we are dealing with AC voltage, we are telling only the RMS value of voltage. For example, if we are telling it as 230 volt or 220 volt AC or 230 volt AC, we are telling the RMS value. Okay. So what will be the peak value? Peak value will be root 2 times the RMS value. Okay. So when we are specifying 230 volt or 220 volt, we are specifying the RMS value. Okay. And its peak value will be root 2 times the RMS value. That's why normally it is said that for the same voltage AC and DC, if it is there, AC is more dangerous than DC because the peak value will be root 2 times that value. So that's why we used to say that AC is more dangerous than DC for the same voltage of AC and DC is there. Okay, is it clear? And now we will discuss about phasor diagram or Argand diagram or Argand diagram. So here we are representing this voltage, AC voltage and AC current as phasors. Phasors means rotating vector. Okay, it can be represented as a vector which is rotating in anti-clockwise direction. We are representing it as anti-clockwise direction. Okay, so such type of diagram in which we are representing AC voltage and AC current of same frequency as rotating vectors, that is known as phasor diagram. For example, we know that EMF is equal to E0 or voltage is given by E0 sin omega. So this how we can represent in phasor diagram that we are discussing. So here X and Y coordinates are there. So here we are representing it as a vector whose length is equal to the peak value. Okay, so this will be the peak value of voltage, and this angle will be, what will be the angle? Omega t. And what is E0 sin omega t? That will be the projection of this vector along y. So this will be equal to E, and that is given by, what is this? E0 sin. Okay, so we can represent it as a vector. We can represent it as a vector whose length is equal to the peak value of that vector and whose angle is given by the sin omega t or whatever it is represent, omega t plus phi, whatever it is. So that. Okay. So if another vector is there, the same. If another vector is there, if it is written like this, I is equal to I0 sin omega t plus phi. So how we can represent that vector? So that can be represented like this. So we can represent both in one. How? This is X and Y. So here this corresponding to E0 with an angle omega t And here what is another vector is that I is equal to I0 sin omega. So if we are considering I0 has smaller length, in problems it will be given, values will be given, or you will know that whether it is larger or smaller. So here we are assuming that it is having smaller peak value than I0. So how we can represent? Okay. And this angle will be phi. So total angle will be, what you will get? This will be corresponding to I0. So total angle will be omega. So we can say that here current is leading voltage. Current is leading voltage because current is ahead of voltage by an angle phi, by a phase angle of phi. So we can say that current is leading the voltage by phi, or we can say that voltage is lagging current by an angle. Okay. So this is what is meant by Argand diagram or phasor diagram. There we are representing it as rotating vector whose length is equal, that is very much important, whose length is equal to the peak value and its projection along y-axis. Because if we are resolving this vector into components, we can see that cos omega t will be along horizontal this direction and sin omega t along vertical direction. So we can say that its projection along y direction is the instantaneous value of voltage or current. And this is what is meant by phasor diagram. Is it clear? And now we will discuss about if we are applying AC voltage to a resistor, what will happen? That we are going to discuss. Okay? Is it clear? So here we are going to discuss about the relationship between voltage and current when AC is applied across a resistor. AC across a resistor. AC voltage is applied across a resistor. Okay. How AC voltage is represented? AC voltage is represented like this. This shows that AC voltage. Okay. So here, if AC voltage is applied across a resistor, what is the relation between current and voltage? Okay. So we are considering a resistor having resistance R. It is connected to an AC voltage which is given by E is equal to E0 sin omega. It is connected to an AC voltage which is given by E is equal to E0 sin omega t, and R is the resistance and the resistance of that circuit. Okay. And if I is the current flowing through this, okay, I is the current flowing through this, according to Kirchhoff's rules, or we can write it as I into R is equal to E, or we can write I into R is equal to E0 sin omega. We write I into R is equal to E0 sin omega t by applying Kirchhoff's rules. Okay. Or we can write I is equal to E0 by R into sin omega. E0 by R into sin omega. E0 peak value of voltage is constant, and for a given circuit resistance also constant. So we can write this as I0 sin omega, where we can write I0 is equal to E0 by E0 equal to E0 by. So we got the relation. Already we know the expression for current EMF, and we got the relation for current. So we can say that from these expressions both are having same angle. So we can say that voltage and current are in same phase. Okay, both are having same angle. There is no phase difference between voltage and current. Okay, so how we can represent it graphically? Graphically we can represent like this. Graphical representation. both should be of same. Okay. That is omega t, and here it is E and I, both we are representing. So if we are representing this both E, this is peak value of voltage, that is given by E0. Now what happens to current? It is E0 by R. Resistance is a positive one. So no doubt this will be small. So we can represent, we can show like this. So this corresponds to this. Okay, so we can say that from this also we can say that both are in same phase. Why? When one reaches maximum, other also reaching maximum. When one reaches minimum, other also reaching minimum. So we can say that voltage and current are in phase. And if we are representing the phasor diagram, what happens? So we are representing by phasor diagram. Voltage, what is the expression for voltage? E is equal to E0 sin omega. So this corresponds to E0. And current is given by I is equal to I0 sin omega t. So both are along the same direction. Both are having same phase. So from this also we can say that voltage and current are in same phase. Over here also we can say. We can write E and I are in same phase. So when one quantity reaches maximum, other quantity also reaches maximum, and when one quantity reaches minimum value, other quantity also reaches minimum. This is what is meant by same phase. Okay. And now we will discuss one or two problems based on this and we will close it. Okay. The instantaneous value of AC voltage is given by E is equal to 300 sin 300. Find the RMS value and find the RMS value and frequency of this. Find the RMS value and frequency of AC voltage. Okay, so here it is given, but it is given is equal to 0 sin omega t. So you can compare it with the equation 300 sin 300 t. So if you compare, what you will get? Peak value, you will get it as V0 is equal to 300 and omega is equal to 300. Omega is equal to 300 and omega can be written as 2 pi f is equal to 300, or f is equal to 300 divided by 2 pi, or we can write it as 150 by 5. Okay, 150 by 5. And you got the peak value, and how to find the RMS value? RMS equal to RMS equal to V0 by, or V0 is equal to, V0 is given 300, so RMS equal to 300 divided by, or you can write it as 300 into root 2 by this is the RMS value. Okay, RMS value is equal to peak value by 2. Okay, so peak value is given, RMS value given. But sometimes they will give RMS value and you have to find the peak value. Okay, and so or sometimes they will give frequency and they will ask you to represent in instantaneous value. How to represent frequency will be given. So you can write it as 0 sin omega t. So peak value is given sin into frequency and then omega can be written as 2 pi f by using that as well. Okay. So next question we will discuss. Calculate the RMS value of RMS value of current. Calculate the RMS value of current. Okay. You have to find the RMS value. Here it is given minus 2 and here it is given plus 2. This is t. This is. So how here if it is given peak value it is given, you can find here it is represented as omega t. You can write this is will be corresponding to I0 by using that here you can find. Here how to find what is meant by RMS. RMS means root mean square. So you have to square the value, then you have to find mean and then you have to find the root. So you can write IRMS is equal to root squaring means minus 2, sorry, here it is plus 2 and here it is minus 2. So plus 2 square plus minus 2 square plus 2 square divided by 3 values. Okay. What you will get? You will get it as 4 plus 4 plus 4, 12, 12 by 3, 4. So you get the answer as 2. Okay. It is represented as, and here we can write 2. Is it clear to everyone? So today we discussed problems related to instantaneous value of AC and RMS value and relation between peak value and RMS value and how to find RMS value if graph is given. If here it is represented as omega t, you have to write a peak value by root 2, that formula in the. Okay, is it clear?